Okay, great. Okay, so basically tonight and all the next office sessions until all the assignments are due, basically going to look at questions that you might get, and nearly working through a few of them. So the pack that I've created for tonight and maybe the next session, it's not how you would get in the assignments. I did not add options or anything. So it is more to show how we will work it out in any case. And I think that will be valuable as well, so that we can see how our processes work, how we need to do it. After this set of questions, I will also then put together some questions from previous assignments and things like that, as nearly another one that we can work through. Okay, so let me just get all the things right. Okay, so again, this covers nearly all the topics. So you will see that we'll start off with some basics, then we'll get into some stats. Perfect, no worry at all. When it's sorted, you can just speak. Yeah, so basically just a random number of questions. So let's start with this one. In here you can see we get a a definition equation that we're working with, and they give us then things that we need to work out. So if x is equal to 4, find the value of a sum from t equal to 0 to where t is equal to 3. I don't understand why they just didn't from the start write it as 5 plus 4 to the power of t. They could have done that from the start. They didn't need to even include to say if x is 4. They could have just done it from the start. So basically, we're going to work that out from t that is equal to 0, then 1, then 2, then 3, and then we're going to add all of them together. Okay, so the first one is then 5 plus 4 to the power of 0. Then the next one will be 5 plus 4 to the power of... Ooh, wait. Okay, let me just view back again. Okay, so then there's a 1. You don't need to write the 1. It can also just be not there. Then 5 plus 4 to the power of 2. And the last one, 5 plus 4 to the power of 3, and then... Okay, so in the first one, we have 5 plus 4 to the power of 0 is 1. So anything, if we have t to the power of 0, it will be 1. Everything to the power of 0 will always be equal to 1. So that first one will be 5 plus 1, which would be 6. Just then 4 to the power of 1, it stays 4. If we then take the square root of 4, it will be 2. So the square root of 4 is 2. When we look at 4 to the power of 2 and we take the square root of it, we basically cancel out. So that will be then 5 plus 4, which is equal to 9. And then the last one is when we get 5 plus 4 to the power of 3. So 4 to the power of 3 is 64. So it's just, it's 5 plus square root of 64, which is then actually 5 plus 8, which is 13. Okay, and then to get to the sum, we just need to say 6 plus 7 plus 9 plus 13, and that will give us the answer of 35. Okay, so there's not nearly another way of doing it than by substituting. Substitute from 0 to 3 means that you need to say, when is it when t is equal to 0, t is equal to 1, 2, and 3, and then you add all of them together. Okay. So basic substitution that you did here, and then just the trick in adding all of them together. Okay. The next one, then we go into a bit more of solving for x in the equation. In this one, when you look at it, we've got divided by 4 for 2 of them. The other one divided by 2. So what I would first do is to say, okay, how can we create that everything is divided by 4, then one can work with it much better. So to do that, I basically on this side need to multiply the top and the bottom by 2. So that will give me 2, 1 minus 5x over 4. And on the other side, I have 3x minus 2. You can actually add that one to it over 4. And then, because both sides are divided by 4, I can just take that away, so that I'm left with 3x minus 3 on the one side. And if I multiply that in, I get 2 minus 10x on the other side. And then I always want to work with x being positive. So I'll take the minus 10 over to the other side. So it becomes positive, which makes it then 13x. And then I need to take the -3 to this side, which will make it +3. So +3 plus 2 give me 5. So then x is just 5 divided by the 13. Okay, so the easiest for me was nearly to see how I can change that 2 into a 4 so that I have straight through at the bottom 4 so that I can eliminate the 4s, and then I can just nearly simplify the equations which are at the top, to get to one simplified answer. Okay, so that was nearly looking at it from simplification, where you divide it by something and you could then simplify it by changing what you're dividing it by. Okay. Okay, so then the next question that we're looking at is uh, and it is very similar to solve for x, so I just using R, but basically we need to solve for R. We've got a square root on this side, so what I first will do is I'll simplify it in a way that I've got the square root on the one side, and then the rest on the other side. So 4r plus 3 square root is equal to 3, and let's just say we take the -2 over. So if we take the -2 over, it is 3 plus 2, which is 5. Okay, so now the next step is to say, okay, I need to get rid of the square root. So how I get rid of the square root is to basically take to the power of 2. So there's normally a 2 in that, or they don't show the 2, but there is a 2 in that square root because that's the standard one. So if I take square on the one side, I need to do the same on the other side. And by this method, I now have been able to cancel that out. So I sit on the one side with 4r plus 3, and on the other side, 25. And then again, we follow the same principle. Make it 4r on this side, take the 3 over to that side. So from left to right, we take it, so it becomes 25 minus 3, which is 22. And then R will be 22 divided by 4. And that can now be written as 22 divided by 4. We can maybe say, well, it's 11 divided by 2, or we can say it is 5.5. So again, then depending on how the final answer look, you can nearly simplify that from there to there. If it's still not the answer and you simplify it to the next one, maybe it is then what the answer is. So again, I don't simplify at the beginning, just to make sure that whenever you get your final set of answers, that one of them will be will be the one that you need to look out for. Okay, so basically in this one, we first needed to get rid of the square root. How we got rid of that is we took to the power of 2 on both sides, and then you just use simple or simplification to get to the answer. Okay, so let's then look at the next one. So this I would normally put first and then go into finding x and r and t values. But for this, we basically need to solve the expression or find the final answer nearly for the expression. So again, firstly, we look at the things that we divide by. Phew, there's not really anything nice in here. It's probably 8, 4, 5, probably 8 times 5. So we probably will need to work with something over 40. So let's first multiply this out before we now start to put it on over something of 40. Okay, so 8 times 4 is 32. 32 plus 5 is 37. So 37 over 8. Then 4 times 3 is 12 plus 1 is 13 over 4. And then we need to add the 5 plus, or 5 times 1 is 5 plus 1, 6 over 5. Okay, so let's just do times 40. So 8 times 5 will give you 40. So both sides, or for this one, I'll basically need to multiply 5 by 5. So 37 times 5 gives me, sure, wait, I think I made a mistake. 37 times 5, yeah, 185. Then I need to subtract 13 over 4. So to get to the 40, I need to multiply by 10 over 10. So 4 times 10 is 40. 13 times 10 is 150. And to get from the 5 to the 40, need to times by 8. So 5 times 8 is 40. 6 times 8 is 40, 48? No, let me just 6 times 8. Yeah, 48. Okay, so then we sit with 185 minus 150 plus 48. So 103 over 40. So that is 2 that we can take out. 2 times 40 is 80. 103 minus 80 is 23 divided by 40. And I think that is, I think sorry, I think 23 is a prime number as well, so we can't really do anything with that. So then your final answer will stay at 2 and 23 over 40. But once again, they can have both of these as final answers. This one is more likely that they will simplify it to 2 and 23 over 40 instead of 103 over 40. Okay, so that is where you basically need to simplify by using improper fractions. Then the next one is simplification, but now we are using exponents, we're using different denominators, we have a few different things. So what we can do is simplify this in a few ways. So for me, if I look at 8, I can simplify 8 by saying that is 2 to the power of 3. Because it will be 2 times 2 times 2 will give you 8. So at the top, we basically have 2 times, or 2 to the power of 3x. So we just change that into 3x, and that multiply then by 3 times 3x. So we can nearly create that already as, so let's keep it as 3 times 3x, or we can change it into 3 times 3 is 9, 9x if we want to. At the bottom, we're sitting with 2 to the power of 3x. So that we're going to keep for now. And when we sit here, what we can look at is to change it to 4 can be changed to 2 to the power of 2. So we're actually sitting here with 2 to the power of 2x plus 2. Okay, so what I then would have done is to say, okay, that I automatically nearly cancels out, but then let's write a bit more of what is left. So at the top, I'm still left with 2 to the power of 9x. At the bottom, I have 2 to the power of 2x times 2 to the power of 4. And then I can cancel out 2 to the power of 2x. Then the top one will change from 9 minus 2, so the top one will become 7x, which then leaves me with 2 to the power of 7x divided by 2 to the power of 4. And then again, depending on how your final answer looks like, it can be kept as that, or it might even be 2 to the power of 7x divided, and then if you multiply 2 to the power of 4 out, you get 16. So that could have been your other solution. So again, depending on in your assignments what you nearly end up with, again, stop there, or if you don't find that answer, simplify a bit more to get to the next one. Okay, but what we needed to do was, for the 8s, we needed nearly to see, okay, if we simplify that, how can we simplify it? That we can use exponents, and how we do that is 8 can be simplified as 2 to the power of 3. And then we need to remember again also that 4 can be simplified as 2 to the power of 2. And then we basically use that to multiply in the x plus 2. And then we just see which ones we can eliminate at the top and the bottom. And then when we get to the final answer, depending on what your final answers will be in the assignments, you can leave it as that, or sometimes they will want you to actually multiply that out. Okay, so that's another question, basically just on simplification, but using some of your exponents into it, and nearly to see when you use the exponents what nearly will be left over. Okay, then the next one, another simplification. In this one, it's a bit different. It's we having exponents that are fractions. So now we need to nearly remember what the rules are with fractions, and how we work that out. So if you look at this one, it's nearly to say, okay, but let's work out a fraction component first. We know when we multiply our two exponents, we add the two together. So let's see if we then work with just the 2 over 5 plus 2 over 3, if we can add that up. And the easiest way to add that up is actually to make your common denominator 15. So to get from 5 to 15, we needed to multiply by 3. So at the top, 2 times 3 will be 6. To get from 3 to 15, I needed to multiply by 5. So to get from 2, I need to multiply by 5, so I get 10. So this is actually 16 over 15. So my top one now, if I simplify that, is actually x to the power of 16 over 15. And then at the bottom, only thing I can think of at the moment here is to divide both by 2, so that I sit with x minus 1 over 2. Okay, so probably they will not want you to end it like this. If this is one of the answers, then please don't continue trying to solve it any further. But probably they want you to move on from here, to see if you can't simplify it a bit more. So how we can nearly look at it is to say, okay, well, again, we've got the same x is in both, so we can rewrite this to say, well, it's X 16 over 15. And then what I do, I bring this to the top. When I bring that to the top, just remember I need to say minus minus a half. So I will actually, the minus minus a half will change into a positive. So we will now have 16 over 15 plus a half. And now we can do the same with that as we did in this instance. So we do the same principle we follow. Again, if I look at this, I don't see anything except nearly 50 that we can use as the common denominator. So if I use 50, 15 to 50 is times 2, so 16 times 2 is 52. Then from 2 to 15 is times of from 2 to 50 is times 15. So 1 times 15 is 15. So that will become 47 over 50. So your final answer looks like 47 over 50. I don't know if you can actually change that too much. So what can happen is that it might be x1 and 17 over 30 maybe. So again, nearly look at if this is one of the final answers, go for it. Don't even try to simplify it. If you don't get this one, then probably what they wanted was that you take out one at least, and then what you're left with is 17 over 30. Okay, so then that's basically then looking at the mixed numbers as well. Okay, Graham, just a thumbs up if everything is still good. Except that you can't speak at the moment. Okay, so the next one, we're changing the format a bit. So we're looking at a word sum. So cool. So Denzel buys 300 outdoor refuge bags for 300 rand. So I assume that it is 300 rand for all 300. He sells them for 25 rand 99 for a pack of 30. How much profit did he make? Okay, so if he buys 300 bags for 300 rand, it feels to me that he is buying each bag for 1 rand. So if he packaged 20 of them, I would have just said multiplied by 20. So 20 of them should be the value of 20 rand. If he sells them for 25.99, he's basically making, let's see, 25.99 minus 20. So he's making a profit of R5.99 per 20 bags. So I think that is just important that we say per 20. Sounds like cigarettes, between pack of 20. And then to get to the 300 bags that he got, so that would then be 300 divided by 20 to see how many packs he does get. So if you say 300 divided by 20, he actually is making 15 packs. So if he gets R5.99 profit on each pack, you will just say that, well, there's 15 packs, R5.99 profit per pack. So if you multiply the two out, you should get the profit that he is making on all the bags that he bought, which will be 89 rand and 85 cents. Okay, so if they ask you how much profit did he make per 20 bags, it will be R5.99. If I ask you how much did he make for all 300 bags, it is 89.85 rand. So again, depending on they can ask you how much profit did you make in total, how much profit did you make per 20 bags. Yeah, so they can nearly phrase that last part of a question in a few different ways to nearly test if you can get to an answer for that. And then if you understand just how to get, so if I said 4 bags, how to get to the 4 bags, so that you multiply the R5.99 by 4, and so forth. Okay, so that is one of the word sums. There will be another word sum coming up a bit later. But what I now have is the stats question. So, and just I'm now thinking, it's you guys are doing this, you are allowed to use Excel. So I'm just going to type in the numbers into Excel, then I will show you how I'm doing it, so that you can, and then I'll share the Excel on the WhatsApp group as well, because I think that will be valuable. Because what I'll do is I include now into the Excel, I will include the Excel functions, but also the functions of how you need to get to it. So I just want to, let's just so let me, okay, so, and let's just make the view a bit bigger so that you can at least see. Okay, not that big, but that's also fine. Okay, so here's your set of data. They ask us to work out the average income. So to work out the average, there is a function in Excel that is just called average, and we can take all of those values into the function. But what we can also do is to say, but okay, how are we normally calculating the average. So normally we would take the sum of all the values and we will divide it by how many values there are. So we can divide it by the count of values. And you will see if we use Excel or if we use the maths formula, we get the same answer. Okay, so what you can do when you now get an assignment, you can, if you change this, it will automatically change the answer for you. So you can just, when you get it in an assignment, you can just use this part. So I'm just gonna, let's just do that. Let's just see what else is in this. So median of the incomes. So median is quite interesting. So for me to do the median with this set of data, let me first use the Excel one. So Excel will look at the data, it will find your median, which will be 1900. But what you will need to do if you not using the Excel function is that you first will need to sort this data. So let's do that. We can sort the data and you will see it will not change. Wait. So what, let me just move this down that it doesn't see everything as being part of that. Cool. So we sorted the data. We didn't change anything here. So to get to the median, we will need to get what is the middle value. So there's 1, 2, 3, 4, 5 on this side. 1, 2, 3, 4, 5. So we know that we can work it out as having what's the difference between those two values. So it is 2000 minus, okay, so let's rather do it the other way around. So what is sitting in the middle of those two? So in between 1800 and 2000 is 1900. So how we could have done it was to say, well, it is for 1800 plus the difference of, if you're adding the two together, minus or plus that difference, sorry. So the 1800 plus the difference of those two, which also will give you the 1900. So again, it didn't really matter if you used the Excel or the math formula, you would have gotten the same answer. Mode of income. So, and the other name for average is also mean, if we need to get that. Mode of income basically looks at the number that appears the most. So again, if you look at this data set, there is actually a number that appears twice. So that would have been, there's no math formula for it. We would just say that was a number that appeared twice, but again, there is a mode function in Excel that would have given you the same answer. Okay, now we're getting to something that if you need to work out, so they didn't ask you to work out the variance, but from variance, we normally go into standard deviation. But again, we can work out the standard deviation by looking at a standard deviation formula in Excel. But also we can work it out with the formulas that they provide in a textbook. Again, it normally takes a bit longer. So what I normally do is I build it into this nearly to say, okay, but if what I can do is to say, because how we normally work it out is to say, I need to take the X value minus the mean, and that value I need to multiply by itself, or need to take to the power of 2. I need to do that for all of them. Then normally what I need to do is to say, well, I take the sum of that and I need to divide it by n minus 1, which is 9. So, but that what we've actually worked out here is variance. And let's change this one to variance. That we first work out the variance and hopefully get the same answer. And so I'm going to move that in, to move that into that space. I'm going to round it off so that it looks exactly the same. So you will see for the variance that we calculated by using that formula, we got it. So if I then take the standard deviation and use the standard deviation formula, for this one, I just put in the data. For this one, I just take the square root of that because that is supposed to give me the same answer, which it does. And then I just, again, round it off so that it looks the same. Okay, so by looking at this, we basically could work out the average or the mean by using all the Excel function, or by looking at the mass function, the median exactly the same. What I can, so let's change this a bit, but we still get to the same answer for you, so that if you change the data, it will now also move. Okay, the mode, you basically look at the one that happens the most. Variance, we've calculated both with the Excel and with the formula exactly the same. And then standard deviation with the formula, and if we square root it, we get the same values as well. So again, depending on what you need to use it for, you can use this spreadsheet. Let me just call it, I'm just going to call it central numbers, because it then refers to your central tendency, which is your mean, median, and mode, and then dispersion or central dispersion, which means that looks at your variance, standard deviation. If there was a range, we could have added that. And then for quartile deviation, okay, so this is a weird one, quartile deviation. So I normally understand it as interquartile range. So interquartile range, that can't be spelled correctly. It just feels it's actually spelled right. So interquartile range, which normally looks at your Q3 minus your Q1. And what we could have done here is, again, so there is a function in Excel that looks at your quartile. So we could say, we look at it, we've got that array. We're looking at quartile 3. But then, okay, so let's do it this way. But it also makes, okay, cool. Okay, so I'll work that into our session next time. Quickly check. Okay, cool. I'll work that into our session next time. Yes, with it, differentiation stuff. Yes, cool. I'll create that for our session next time. And then I'll move some of these questions to later on, and I'll just include that into that session. Graham, what will be a good time for the next session again? As we are now nearly speaking, what will be a good time? So you can just type if it needs to be next week again in the week, or if we need to do something on Saturday, but you can say, I think probably next week in the week will be good again. But yeah, check the exam table for me, and you can then just let me know on the WhatsApp group, because I also don't want to, the exam is, the exam table is much more important to look at that. So then basically what I did was to say, okay, your interquartile range is looking at your Q3 minus Q1. I've now looked at, so what they call quartile deviation. I see there's a formula that says it is actually Q3 minus Q1 divided by 2. So let's see if it, so then that would have been your interquartile range, or your quartile deviation. I wonder if there's actually a formula for that. No. Yeah, thought so. Okay, so So that will be then how you look at it from quartile. Just want to check that. That is correct. I think it is. It looks at the array, looks at, yes. Okay, so yeah, so you can use this basically formula for that question that looks at, and I'm now going to take that out, but that looks at average, median, mode, variance, standard deviation, your interquartile range, and then quartile deviation as well. And we can, yeah, so I'll share, sorry, I'll share it back onto the group as well, so that you also have it to assist you. Okay, the 13th. Okay, so the 2nd June is, what's that, on Friday. So let me check what, so the 13th, let's see how many sessions we can get in the week to cover you for up until the 13th. But let me know then on the WhatsApp group if you have any exams that is also up in the next 2 weeks nearly. But else I think we can definitely look at next week, even a Tuesday and a Wednesday maybe, because that nearly will get us Tuesday, Wednesday is the 6th and the 7th, and maybe even then the Monday, the 12th. We can maybe push in another one before you need to then submit on the 13th, that last one. Yeah, so definitely let's chat on our WhatsApp to next week, and most likely on the Monday before you submit on the Tuesday, I think will also be good. Okay, so this question, I calculated via Excel, and again, yes, you can use your calculator, but let's be honest, if you can use Excel, why not? It is much more simpler to do it with Excel. So again, I will share this so that you can manipulate this data, and the rest of the answers will follow onto that. Okay, yeah, so they will definitely, this was part of that last part of the study unit. So you'll definitely, it will be in this assignment, and then it will definitely be something like this in your last assignment, where it covers the whole book nearly. Did they say how many questions, or how many questions was in your in assignment, what was it, 13? And have they said anything about how many questions will be in the last assignment? Because also it's easy to say it covers everything, but I'm hoping that they give you at least some guidance on how many questions there are and things like that. Okay, so let's look at, and yes, the recording will be available. Will in any case, download it again after this session, and then I'll share it on the WhatsApp group as well. So no worries, it will be available. Okay, so then probably again you're looking at around 20 questions. So for your last assignment, you can nearly then think about 20 to 25 questions in total. And I think there was about seven chapters, I think. So about 2-3 questions per chapter that you will probably look at. Okay, part of this stats component. Yes, so and let's first draw the box and whisker. And let's see what's in it. So the box and whisker, sometimes they call it the 5-plot diagram as well. So what it does is it looks at your minimum value. At the top, it has your maximum. Then that first line is Q1. The second line is Q2, sorry, or your median. And your third line there is Q3. So if I look at this data set, you basically, that is the values that you need to find. So if I look at your minimum, okay, it was 3. Maximum seems like 18. And then I would go to Excel again for, let's say, box and whisker. And I would then use Excel to work out again the Q1, Q2, and Q3. But that's weird. Why? Okay, so let me just look at the data. And let's again first put in the unordered data. We will be able to order it also in Excel, so don't worry too much about the order for now. Okay, so there's the set of data. Again, if we work in Excel, we don't need to order that. And with the functions in Excel, we can get to the minimum of that. We said it's free. Let's just make sure it is free. And let's do it a bit different. I'll move things around now so that you nearly have it in the format of a box and whisker. Okay, so we're looking at the minimum. We also said it's free when we looked at the data. The maximum was 18, we said, so let's just check. Yes, it is 18. So then if I use this function of the quartiles for quartile 1, we work it out and your value is 4. for quartile 2, 3, we work it out. So again, looking at that, put in 3, it is 14.5. So again, if you need to round it off, look at what is nearly in the box and whisker. If I draw it for you, then you can round it off to 15, but else again it's fine to keep it at 14.5. And quartile 2, let's do it on 2 ways so that you can also just see that. So if you use the function quartile 2, and if you use the function of median, you're getting the same number. So you've got, then you can draw that as 3, 4, 10 or 11, 14 or 15, and 18. So we could have said that is 3, that is 4, what was 10.5, and then I think it was 14.5, or was it 15.5? I was at 14.5. And there it would have been if we needed to plot the data. So again, they can't ask you to plot the data, but they can give you a few box and whisker plots and say to you, okay, well, here's the data, here are 4 or 5 box whisker plots, select the one that represents the data. And then normally it's easy to do the minimum and maximum. It's also sometimes easy to do the mean or the median if you arrange it, but then to do Q1 and Q3, I will again use the formulas that are provided. Okay, so that is on box and whisker. So we have so in a lot that I've seen in some of the stats modules, and it would be interesting, Graham, if out of that assignment that you guys now did, that is due in, I think, 2 days' time, how they, if there was anything on box and whisker and how they ask that. So yeah, so that would be just interesting to see how they ask it, because I've seen that sometimes they give you nearly a set of 5 numbers, and then they give you a few box and whiskers and say which one is representative of the data, or they give you a bigger number of data, but again ask you which one is representative, and you need to choose. So that might be probably how they will ask it in the assignments as well, because I'll also like to, when I look at this, to throw in the box and whisker, because it tests Q1, it tests your Q3, it tests your median, and then the minimum and maximum, it just adds that. So instead of nearly asking it in this instance, you're already asking it in a perceived easier way, but yeah, you still need to know how to calculate it. Okay, and then and again, how your last assignment will be, it will be a mixed bag of questions. So now they go into a word sum, but a word sum with an equation linked to it. So they say that the population level in the city center at 6 in the morning is 25 parts per million particles, and it grows linear by 30 parts per million particles every hour. Determine the linear equation that relates the population Y when elapsed time X. Okay, so in this instance, if I look at this question, so when you start off with a measurement, there's 25 parts. So however my that would look like, I know that when X is 0, I start off with 25. Then it says as it grows linear by 30 parts per million particles every hour. So as X increases, it increases by 30 parts per million particles. So every time we go up an hour, it goes up by 30. So if it is 2 hours, it will go up by 60. If it's 3 hours, so in words, this is actually just the formula that they wanted. They could have asked then, what is it after 5 hours or something like that? So that with the formula, you need to then put in 5 into the X, so that they could have asked you to do the equation plus answer for Y, which then will be 150 plus the 25, that will be 150 or 75. So they could ask you only to write down the equation. They could have asked you to substitute or add things in it so that you can get an answer as well. Okay, let's check one more. Okay, then we can end for the evening. Okay, so a tutor at a college is required to do teaching and research for at most 40 hours per week. Okay, so here we're dealing with linear programming, and they ask us nearly to write down the all the different equations that you might get for this. And they will probably say, yeah, let X be the number for research and Y be the time for spending on teaching. So a tutor at a college is required to do teaching and research for at most 40 hours per week. So we know that the first one, I can do teaching, which is Y. They can do research, which is X. But basically, X plus Y cannot be bigger than 40 hours. So can be equal to 40 hours, but can't exceed 40 hours. So we know that nearly the first equation that we can look at is the time for teaching and the time for research is less than or equal to 40. So that is nearly the first equation that we did was with that one. Then his research work pays 30 Rand per hour. So research is X pays 50 Rand per hour. Teaching pays 70 Rand per hour. The tutor needs at least 2,000 per week for his own studies. Okay, so strange question, but so basically, if we look at what the student needs to or what the tutor needs is to make at least 2,000 Rand per week. So at least 2,000 means 2,000 or more. How to get that? He needs to do 30x plus 70y. Okay, so that part, including that, is equal to what we've written down here. And so that is your one equation, and that is your second equation. If we then need to put it into or work it out, they don't ask us to. So this is basically, we have derived the two inequalities from the information that they have given us. Okay, let's do one more, and then we can stop. I saw this in one of the papers as well that I got, and I was like, "Phew, I don't know if you guys did this, but basically what this tells me is when I have an open circle like that, I use those inequalities. If I have a closed circle like that, I use the bigger or equal or the smaller and equal. So I don't know if this is somewhere in your textbook or in your study guide as well. But then basically what this represents is if it was, again, there we see x, so x will be smaller than 9. So imagine that is a 9, or it will be bigger or equal to 4. So you can also write it as x bigger or equal to 4 and x smaller than 9. Okay, so either or is correct, as long as you have it that the closed circle includes the 4 and the open circle excludes the 9. So having x bigger or equal to 4 smaller than 9, or having x bigger or equal to 4 smaller than 9, either one of these are valid. The one that they prefer mostly is the top one, but both of them are correct. Also, so if you see it in this format, you basically read it very similar, because you'll read it as x is bigger or equal to 4, x is smaller than 9. Where this one you just read x is smaller than 9, x is bigger or equal to 4. Okay, cool. So that is it for tonight. I'll set up definitely two more sessions for next week, but we can chat about when next week it will work for you guys on the chat, and then I will also set up time on that 12 for the Monday evening, so that we just, if there's anything still left unanswered, we can chat about it on the Monday. Okay, cool. I will make the recording available as soon as possible, but it will definitely still be tonight. Okay, and Graham, yes, so anybody else that will later on listen to the recording, if there is questions that you want to send on the WhatsApp group, I'll take the questions, Graham, that you now sent, and I'll put it into a presentation that we can go through next week. But as other question comes up, please just post it there, and we'll work through it. So don't worry about that. I'll put it in and we can work through it. Perfect. Have a good evening, everyone, and see you again next week. And if you're writing exams, good luck for the exams that needs to happen. Cool. Until next week.